Hi, I'm Chris Andrews, the Group Product Manager for the Geo-enabled Systems team at Esri, and I'm very happy to be presenting to you today about ArcGIS as a foundation for digital twins. I have been at Esri for about 6 years now. I am currently one of the product management leads in the core team. My background is in 3D, digital cities, AEC, and utilities. I've been working around 3D and AEC for almost 15 years. I've been at Esri for 6 years. Prior to that, I was at Autodesk for 7 years. And then I've also been at IBM and MWH, and then previously in enterprise consulting. Throughout my career, I've really focused on bringing together information from multiple domains to solve problems, whether that's in biology, in engineering, or here at Esri in the GIS field. Our world is transforming. We're moving into a phase where we're able to digitize and digitalize at extremely high detail the real world such that we can abstract and model it, including assets and systems, to create high value digital assets for natural systems, facilities and structures, complex infrastructure such as networks, and then entire cities and communities. GIS provides a framework for creating and integrating these digital assets, which are often referred to as digital twins. Our understanding is that digital twins are virtual representations of the real world, and these representations may include physical objects, processes, relationships, and behaviors. GIS can not only be used to create digital twins of the natural and built environment, it also has the capacity to uniquely integrate many types of digital models. GIS and digital twins helps transform our ability to understand organizations, communities, systems, and the entire world around us. I've been in the field for many years, and early on I started out using GIS for enterprise integration. As many of you know, GIS is a key technology that interconnects and integrates data, people, and systems. GIS can be used for data capture and integration, for real-time visualization, for analysis and prediction, and then one of the key values of GIS is to be able to share and collaborate around complex concepts and systems that can be easily understood on a map. GIS enables us to integrate digital twins. It's not possible to represent every aspect of a complex system or asset in a single digital model, especially not when these models are tied in with real-world systems that might extend outside the boundary of control of our customers. We believe that there isn't one digital twin that represents every complex asset around the world. What we see is that there is evolving a system of many integrated digital twins, or system of systems, that interconnect content, behavior, and workflows. So whether you're looking at asset management or design and engineering problems, construction management, you're trying to constrain emissions and waste or optimize use of natural resources, we feel that many different information models can be brought together through the concept of integrated digital twins to achieve project outcomes such as increasing transparency and sustainability, improving communication across different project teams and stakeholders, higher decision confidence, and then certainly optimizing processes and mitigating risk. So integrated digital twins enables dynamic outcomes and analysis, and spatial becomes a key component that ties all of these twins together. GIS enables data capture, integration, and management. We have invested heavily recently in acquiring two smaller companies that are focused on an area called reality capture, which is quite exciting because we are increasing the ability of our users to be able to capture reality, collect LiDAR and photogrammetry, and directly create 3D assets that can be used in GIS from those data. GIS is used for data modeling, including just the concept of bringing together multiple data sets into single maps and scenes so that they can be viewed, analyzed, and collaborated upon together. And these data sources can include everything from reality capture to traditional 2D GIS data to BIM and other assets coming out of the construction and engineering world. And then, of course, GIS has been used for data integration and management for years. And GIS has been part of a key part of many efforts to integrate systems across very complex government, construction systems, and others. GIS enables dynamic visualization put into user-friendly experiences that are accessible to anybody over the web or even on mobile devices. We are seeing real users do things such as the 5D visualization dashboard up there in the upper right, where one of our partners, HNCB, created the ability on the web for a customer to actually see project outcomes and actually experiment with the delivery outcomes based upon availability of assets and timing of installation. Really exciting to see this kind of thing coming from real customers. We see GIS used as a digital twin for real-time operations in the field or on the desktop, and then certainly to visualize trends and explore both inside and outside buildings and structures. GIS supports sharing and collaboration. A key facet of ArcGIS for years has been the ability to serve a map or story map or a web scene online so that multiple stakeholders can explore it, interact around it, and then understand what their contractors or consultants or data providers are providing. GIS is used for stakeholder engagement and management, such as by this really fantastic project from Norman, Disney, and Young, where they built a story map and integrated Esri 3D to show the renovation status of the Circular Quay project in Australia. It's a fantastic example of something that's not just art of the possible, but actually possible for any customer using ArcGIS. GIS helps transform digital workflows by providing insights that actually can impact outcomes. GIS can be used to help classify reality capture data. Machine learning and AI modeling can be used to extract information from captured data. And then we can build models to help predict outcomes from change that is being planned to be implemented in large systems or environments. For example, ArcGIS provides capabilities to understand elevation-based suitability, forecast time series, and to optimize routes. ArcGIS is a broad system that provides a wide variety of capabilities that support digital twins of all types. We have capability to help customers with data capture and integration. We have capabilities for visualization and real-time awareness, sharing and collaboration, and analysis and prediction. And ArcGIS is integrated into thousands of digital representations of real-world systems through our APIs and SDKs. If we look at digital twins, we actually see that there are three key problem areas where our users are interested in having digital twin representations of their systems. One is to simply capture a historical record or baseline. One of the most fundamental questions that we get, especially when it comes to 3D, is how do we get started? And actually, many of our customers have been building digital twins of their assets for 20 or 30 years using 2D GIS. So that is obviously a key starting point. But now we also see the ability to capture realistic 3D representations of assets, and we do see this being done just for purposes of record keeping. We also get probably the biggest component of demand around digital twins is for dashboard views into the operational performance of real-world systems. This can be cities, it can be utility assets, or even other systems such as trucking and shipping lines. We also find that in many cases, customers don't yet have their assets in the state where they want them to be in the future, so they're actually interested in a digital twin that can help them test and predict future outcomes. It's important to consider that any digital twin effort is really a complicated IT investment that is going to require change management and ongoing work with people and processes to make sure that the digital twin starts out understanding the right constraints and requirements and then achieves the desired outcomes and then is sustained to keep achieving outcomes and possibly be extended to new outcomes. Digital twins are often built for a finite set of purposes, but then expected to be able to be used across many different new applications. That's only ever going to be possible if organizations understand that will require continued investment and support for the people and data and systems that go into making up that digital twin. As you know, Esri has a deep commitment to open software standards and data, and we believe that these are critical components of the success and health of digital twins and will enable the integration of multiple digital twins, as I was speaking about earlier. One area where we have invested heavily is to support an open specification for the exchange of 3D information that we first put forward into the OGC as a community standard several years ago. Now we know that open standard has been adopted by dozens of partners and customers, and it's deeply embedded in Esri's software. In fact, we estimate that there are over 1 million users of ArcGIS Earth, for example, and those users all have access to a client that can read I3S, Index 3D Scene Layers. I3S was designed for cloud, web, and mobile, and it's based on modern web standards and best practices, and it supports all kinds of 3D geospatial content, as well as offline and online workflows. We've implemented several different layer types in I3S. One of the areas where people are getting quite excited these days is for the ability to use reality capture information, such as the meshes that are shown in these videos and images. As you can see, we can even do things with the mesh such as drape 2D content over it so that it actually enhances the user's experience by allowing them to click on the mesh and to see through to the GIS information underneath. And then we've also added capability to do things such as mask out the mesh or clip the mesh down to a limited area so that you can do things such as bring in a proposed development to explore how that's going to look in the middle of a large city. One area that I've been heavily involved with as well is to help move more information from the design and construction world into GIS workflows. We created the building scene layer type in I3S specifically to encapsulate the semantics, graphics, and other metadata of BIM files coming from applications such as Autodesk Revit, for which users really didn't have an option before we released this. Now you can actually stream very large Revit files over the web into a browser, on a phone, or on a desktop, and actually explore what looks and feels like the semantically integrated Revit file with all of its metadata for buildings across large campuses. And we see users building more and more interesting experiences using this capability, and I'm really excited to see where we go with this in the future. To do this, we actually enabled users to take an Autodesk Revit file, or several files, bring them into ArcGIS Pro, and then publish them as building scene layers in a couple different patterns which were then able to be either consumed locally or published up to ArcGIS Online or Enterprise, where they could then be used for visualization, analysis, exploration, and data and asset management. What we're adding in 2021 is the ability to use open standard IFC format from Building Smart International as a very similar in a very similar workflow, pretty much consistent with the Revit workflow, which a user will be able to take an IFC file that represents a building or other structure, bring it in as a building layer in ArcGIS Pro, and then publish it to the same type of building scene layer, retaining as much of the metadata and semantics in the asset as possible. We also believe that IoT integration is a critical component of digital twins, especially for those who want to use them as performance dashboards. Esri has enabled our customers to access real-time sensor feeds from moving and fixed assets through Geo Event Server and to analyze those in the Geo Analytics Server, or in our new ArcGIS Online hosted offering, we allow similar capability through ArcGIS Velocity. Velocity and GeoEvent Server allow us to connect to not only a variety of sensors, but also to other third-party IoT platforms. ArcGIS Urban is the example of a digital twin application that is positioned at future prediction and understanding. And it is also a good case for when customers might not always have 3D and they start out with 2D and help use some of our tools to move toward a 3D geospatial environment. ArcGIS Urban allows customers to work with plans and projects to set indicators and then to communicate about future plans through an intuitive web-based experience. There are also projects and extensions for ArcGIS Urban that let customers do things such as create a tabletop VR experience. If you ask about that, we can point you to some resources online where we actually offer some of those tools for free. Here's just a quick demo of ArcGIS Urban. It is a lightweight, friendly, web-based experience for exploring plans and projects, creating plans, using information such as 3D zoning information to set constraints for evaluating future development. And then, as you can see, it is capable of using both 2D information and 3D information, also pulling from the vast resources of ArcGIS Online in the Living Atlas. ArcGIS Urban rolled out about 2 years ago and is actually now being widely used across many of our key customers. This case, for example, is the city of Honolulu. Arcgis Geobim is a new product that's being introduced this year that is intended to bring together a different side of the digital twin story. We have had demand for many years from our customers and partners to help provide easier experiences for large project teams to look at complex BIM and geospatial information together that cover large, complex projects. In some cases, dozens of projects at the same time. GeoBim brings together ArcGIS Online and Enterprise with, at its initial release, the Autodesk Construction Cloud to provide a single, common, easy-to-use experience for large project teams to explore BIM information and issues in context using ArcGIS capability. In the future, we do plan to integrate additional third-party BIM cloud solutions and data sources, but for our initial release, we are partnering with our alliance partner Autodesk to promote GeoBim and to make sure that we have an experience that meets our customers' demand. GeoBim is intended to transform AEC projects with geospatial context, allowing users to manage risks, costs, and timelines by connecting BIM information and process with location during the design, construction, and operation of capital infrastructure. it's intended to have an easy to use, lightweight experience that actually can be tailored for different project experiences to meet the needs of specific project teams and stakeholders. ArcGIS Geobim's initial release will have limited third-party integration, be focused on ArcGIS Online and Enterprise integrating with the Autodesk Construction Cloud, and users will actually create GeoBim projects that can contain multiple GeoBim apps that can provide a variety of dashboard-like experiences to investigate issues and BIM content in geospatial context over the web. So ArcGIS Geobim is another example of a very lightweight web-based experience that allows our customers to explore 2D and 3D CAD and BIM information in GIS context. In this case, the user is able to switch between 2D and 3D views and explore a potential new constructed building and actually see some of the detailed metadata on the building itself. Also to then pop over and look at the current InDesign version of the same model in the Autodesk Construction Cloud. The user is able to take advantage of some of the interactive tools in both environments to explore their data, and in the future they'll be able to tie that data into project schedules and other aspects of large programs. So we have many customers who are actually implementing their own digital twins. In the urban planning domain, we can see numerous customers have started to take advantage of the capabilities of ArcGIS Urban, including the city of Honolulu that I already showed you, Uppsala, the city of Fullerton, California, and then Boston Planning and Development Agency. We have some fantastic examples from the construction and engineering fields, such as this HNTB-based 5D construction example I showed earlier. In this one, it's fantastic. The construction team was able to incorporate updates within 24 hours of data receipt. I really love that they are able to use this to validate construction sequencing. It's something that people have been asking us to do for years, and it was fantastic to see this customer do it on their own. And it's usable for all kinds of stakeholder review, both inside the large engineering firm and with their end customer stakeholders. And then we see companies such as Hazen and Sawyer who have embraced the digital twin concept for more operations and asset management cases. And in this case, they created an interactive tool for exploring BIM data for a water utility, and they are actually rolling this out for much larger sets of water utility infrastructure with this customer. It's just a fantastic example of taking what we've done in 3D GIS and with BIM GIS integration and putting it together into a workflow based experience that actually helps the customer accomplish real work. All right, so for me, I hope that I've given you a good overview of what's possible with ArcGIS and using ArcGIS as a foundation for digital twins. As you can see, there are a few blogs and other resources that are available for folks to explore. And if you ever have any questions, please feel free to send me an email or contact me on social media. Thank you very much and enjoy your event.